Hello everyone, my name is John Legg and today I'll be going over my Civil Engineering 4210 final project. So I'll be going over problems of smog, what is the problem and why is it a problem, global pollution issues, common areas of concern, and short-term solutions, implementation, and long-term solutions. So basically the background of the problem is high pollution and their emissions. One example is Xi'an, China. The people of Xi'an, China use coal to heat their homes, and their electrical utilities rely on coal power plants to generate electricity for their electrical grid. China has attempted to take some steps to reduce their emissions and reduce the smog in their cities. However, it is not enough. 10 years ago in 2011, I visited Xi'an for a week, and the weather was overcast, not because of natural clouds, but because of pollution and smog clouds. This is an issue in many of the Chinese cities and also other developing areas of the world, such as cities in India. So, what is smog? So, smog is a combination of carbon dioxide, sulfur dioxide, carbon monoxide, and particulate matter, as well as NOx and heavy metals. The most damaging pollutants are the PM 2.5 and PM 10 pollutants. So, basically, with the whole COVID situation, anything that reduces your immune system will likely make your whole COVID experience worse if you get COVID. So essentially, COVID is most likely not going to go away, and at best will turn into an endemic, kind of like the flu. So if smog pollution is so bad, what can we do about it? So transitioning to zero emissions of pollutants globally today is not feasibly due to technological limitations and economic factors. That being said, there are efforts to reduce the emissions of pollutants in many countries around the globe, and this will take many years to do. So why smog is an issue? So essentially there are many health impacts with smog, which include an individual's nervous system, respiratory system, cardiovascular system, and immune system. Common symptoms of pollution exposure include headaches, breathing issues, heart issues, and allergy issues. It has been shown that severe long-term exposure to pollutants decreases life expectancy and reduces quality of life. And the most damaging is the 2.5 and PM10 pollutants. So potential solutions would be to reduce emissions at their source or remove them from the air. The first one would be the most effective, and the second one we will be addressing here. And the factors that influence the exposure are the magnitude, duration, and frequency of the exposure. So for the magnitude, that's basically how much bad stuff is in the air. The duration is how long a person breathes in the bad stuff, and the frequency is how often they do so. So we'll be addressing the magnitude and the duration and frequency, all three of the above. So essentially, the electrical grid is varying, meaning that there's different demands at different times. So during nighttime, there's less of a demand, and during the day, there's a higher demand. And so especially during the summer, there's high demands due to AC, and during the wintertime, there's demands due to heating. So we'll be addressing different types of loads. The base load would be addressed on the valleys of this graph, and then the peak loads would be of the peaks of the graph. So the electrical supply is made up of different components on the American power grid system. So the biggest one is going to be nuclear. Nuclear power reactors generally do not want to vary their electrical output due to their high capital cost and the safety factor involved. They would want to output at a constant level throughout its lifespan of operation. Coal is another one where it takes a few days to turn on and turn off their generation due to their large furnaces, so they usually output roughly the same amount. And then the next one's going to be natural gas. Natural gas and petroleum are able to ramp up and ramp down their supply of electricity to the grid and within minutes versus coal and nuclear where it takes a large amount of time to switch. The issue with wind and solar is that you can't really predict when the wind is going to blow or if there's going to be clouds long term. So it's an unpredictable source of electricity. And then there's other portions to meet the load of the power grid. So in developing areas are include China, India, and other countries in the developing world. So we see that the cost of coal is on the left, which include their building cost and then the cost of fuel. And then in the middle, you can see the cost of nuclear. A proposed solution would be to use nuclear as the base load as opposed to coal, which would reduce the emissions of greenhouse gases and other particulate matter as well. The waste from nuclear reactors is relatively minor. There is the issue with long-term nuclear waste, but that'll be addressed in another slide. So potential problems with nuclear is that some countries can attempt to use nuclear material as weapons grade uranium. So the solution would be to incorporate a fourth generation nuclear reactor instead of coal. The fourth generation nuclear reactor produces much less waste than the conventional old style nuclear reactor that were known, such as Chernobyl and 3 Mile Island. The risk of meltdowns for the fourth generation nuclear reactors is much lower. Also, the nuclear material is mixed in with other materials to make it very non-economical to enrich those products. In addition, the waste produced, instead of lasting 20,000 years, only lasts a few hundred years, which is a lot more manageable than the current legacy systems. So some background on some smog. So China has built a 100-meter tower, a smog tower, and as well as India. So the Chinese smog tower works by first pulling in air through the bottom. Then they have a small greenhouse at the bottom of the tower, which heats the air up, which encourages the convection flow and for it to rise. The second step is that it'll rise through the tower, and the third step is when it's in the tower, it'll be filtered through HEPA filters as well as ionizing radiation. So basically, this is just a giant air filter, and so it's effective in removing PM 2.5 particles, and the process works by sending direct current through the air to produce positive ions in the air, which is a better solution than alternating current, which produces different types of ions. So this system, the DC system, does not produce ozone. So the ionized air attracts undesirable particles such as carbon monoxide and NOx. That air then gets bulkier and attracts the bad stuff, increasing the size and weight of the particle, and then these particles are then easier to possibly filter. This technology is theoretically possible, and there's still ongoing studies on the technology and its effectiveness. And another European scholar and their studio, Rosigrad, they designed a 7-meter tower, and the tower filters roughly 30,000 cubic meters an hour, and the effectiveness is that it's able to filter 70% of PM10 particles and 50% of PM 2.5 particles at the 7-meter tall scale. The effectiveness of these towers is still being studied. The filtration technology would be most effective if used as a building's intake filter system. The best way to utilize this technology would be to incorporate the technology in high-density, high-rise structures and buildings where people work and live. People usually spend most of their time either at home or at work, and so this would address the duration portion of the exposure. So essentially, the modified design would be to place like a modified tower on top of these buildings, but instead of having a tall smokestack, it would just be the greenhouse on top, and then that'll be the air intake into the building to flow down, where the that would be the outlet of the filter. So going down, the first portion would be to pre-filter the air with MERV 14 plus filters to take out the PM10 particles, and then to expose the pollution to non-ionizing direct current ionization particles, and then a cloth carbon fiber filter to filter out gases and odors. It's not really to do this effectively, it's just to do be a pre-filter for the MERV 18 plus filter that'll filter out the PM 2.5 particles. The most expensive filter of the design is going to be the last one, the MERV 18 filter. So these are the design calculations. So I designed it so it'll be a 15-story building and an area of 80 by 80 meters. So it'll be 6,400 square meters. Each floor is going to be roughly 3 meters in height, and the floor volume is going to be just under 20,000 cubic meters per floor. The building volume is going to be just under 300,000 cubic meters. The design goal is to meet 4 air changes per hour. That's to increase the airflow as well as reduce the risk of other viruses such as COVID or other potential outbreaks. So these are the continued design calculations, and the design is in line with claims of the 50% reduction of the PM 2.5 and then 70% reduction in the PM 10 particles. The filtration of gases is very difficult to do and not really a feasible option in the large scale. To address that, that would be addressed through source control and coal plant scrubbing as well to reduce the sulfur dioxide. The short-term solution is to retrofit these filters on top of central air buildings, and the long-term solution is to cut polluters at their source. So it would be to shut down coal-firing power plants and replace them with nuclear power plants, increase our wind and solar technology, as well as investing more money into the storage of energy. Batteries are still way too expensive to be used on a national power grid system. We use them on a small scale to offset the peaks and valleys. Other solutions can involve electric vehicles to be used as a decentralized power bank system to meet the peaks and the valleys to level it off. So in summary, today I went over the problems of smog, why it is a problem, global pollution issues, areas of concern, short-term solutions, the implementation of the design, and long-term solutions. And here are my sources.